Have you ever wondered how one of these massive, state-of-the-art AI models actually gets built? I mean, not just the final thing we see, but every single decision, every piece of data, every line of code, right from the very beginning? Well, today, that's exactly what we're going to do. We're going behind the scenes with Olmo 3 to see how a powerful and completely open AI is built from the ground up. Okay, so let's just dive right into the core of it, because this is the central question, right? In a world where AI development is usually super secretive, super competitive, this one team decided to do the exact opposite. They said, let's build in the open and then release everything. We're not just talking about the model, we're talking about the entire recipe book.
So who are the folks behind this? It's the Allen Institute for AI, or AI2. And it's important to note they're a nonprofit research institute. Their goal isn't to sell you a product. It's to push the entire field of AI research forward using open science. And as you can see, pulling this off took a massive team effort. Now this quote here, this is where things get really interesting. See, most so-called open models, they just give you the final model weights. But the Olmo team, they give you that, plus the training code, all the checkpoints along the way, and get this, the more than 10 trillion tokens of source data they used. A token is basically a piece of a word. This level of transparency is, well, it's pretty much unheard of. It is an absolute gold mine for researchers. So, where do you even start with a project this big? Well, it all starts with the data. You have to think of this first stage, the pre-training, like you're crafting the perfect, most balanced diet for a developing mind. Because what you feed it now is going to determine everything it can do later on. And we are talking about a colossal amount of information, trillions of words and symbols. But here's the thing. You can't just scrape the whole internet and call it a day. The quality and the specific mix of that data are absolutely fundamental. The wrong diet, you get a pretty poorly developed model. So how do you figure out that perfect recipe? Well, the Olmo team used this brilliant method they call swarm-based mixing. Instead of just guessing, they ran thousands of tiny experiments. They trained hundreds of little proxy models, each one on a slightly different mix of data. A little more code here, a bit more science there. Then they just tested which of these tiny AIs did the best on key skills, and they combined all the winning recipes into one master mix for the final big model. And check this out. This shows you the result. On the left, that's kind of the natural mix of topics you'd find just crawling the web. But on the right, that's Olmo 3's final mix. After all those experiments, they found that by dramatically cranking up the amount of high-quality STEM and software development content, they got a much, much more capable model. They literally engineered the diet for performance. But they didn't stop there. They also knew that not all data is created equal. So they developed this system called quality-aware upsampling. It's so clever. First, they ranked all their data by quality and just threw out the bottom 40%. Gone. Then they took the absolute best of the best, the top 5%, and forced the model to read it up to 7 times. It's like making the AI study its most important textbooks over and over and over again. Okay, this brings us to a huge, huge problem in AI development: data contamination. Imagine you train your model for months, right? Then you go to test it on these standard benchmarks to see how smart it is. But what if the answers to those test questions were secretly hiding in your training data the whole time? And that is exactly what they found. The team scanned all their data and discovered that these popular, established datasets were just riddled with questions from the very benchmarks that everybody uses to evaluate their models. So they had to go through and do this meticulous cleaning. And this is so crucial because without this decontamination, the AI isn't really proving it can reason, it's just proving it has a good memory. And that makes the test results totally meaningless. All right, so after that broad general education of pre-training, the model moves on to the next phase, targeted tutoring sessions. This stage is called mid-training, and it's where the AI starts to really hone very specific skills, like advanced math and coding. Now, to do this efficiently, they use this super clever technique called micro-anneals. See, training a giant AI is incredibly expensive. So before they committed a new, specialized dataset to the full training run, they would do these really quick, small-scale tests. It's a way to rapidly find out, hey, does this new math textbook actually make the model better at math? Before you go and spend millions of dollars. And these little tests revealed some pretty fascinating stuff. For example, They found that when they tried to teach the model how to format chat conversations too early using these special tokens, it actually confused the model and hurt its performance on core things like math. It was kind of like trying to teach a student proper essay formatting before they've even mastered basic grammar. So they decided, okay, let's save all of that for the very final finishing stage.
All right, now we're getting to the most sophisticated part of the whole training process. At this point, the model knows a ton of information, but now it has to learn how to apply it. How to reason, how to follow complex instructions, and how to have a helpful conversation. This is where we teach the AI how to think. A core idea here is something called delta learning, and the intuition behind it is really cool. It's that an AI learns best not just by seeing a good answer, but by understanding the contrast, the difference between a really great answer and a rejected, mediocre one. It's that delta, that difference, that holds the most valuable lesson. So, they put this into practice using reinforcement learning. The model generates a response, and then it gets a reward score. For things you can verify, like code or math, it's simple. Did the code run correctly? Yes, it gets a reward of 1. If not, it gets a 0. But for more subjective things, like, was that a good chat response? Well, for that, they use another powerful AI to act as a judge, which gives a more nuanced quality score based on how helpful the answer really was. And would you look at the difference this makes? On the left, you've got an answer from an earlier model. It's fine, but it's long, it's a bit rambling. But on the right, after they did preference tuning that specifically included length control, the answer is direct, it's concise, and it's way more useful. They made a very conscious choice to create a model that just gets straight to the point. So we've just walked through all this incredible technical detail that goes into every single stage. But let's zoom back out and connect this all back to that original mission. Why go to all this trouble just to give it all away? Why does this level of openness matter so much? Because when this team says truly open, it is not just a marketing term. They mean they are releasing everything. The final models, sure, but also all the checkpoints along the way. All the code they use for training and for processing the data. All of that raw, cleaned source data, more than 10 trillion tokens of it. And even the exact data recipes they figured out with all those swarm experiments. It's really that simple and that powerful. All the data, all the code, all the models. This means any researcher anywhere in the world can reproduce their work, build on top of it, find flaws in it, and push the entire field forward. It really democratizes cutting-edge AI research. So the Olmo team has built a state-of-the-art model, and then they handed the entire set of keys to the community. By showing us not just the what, but the how, they've created this incredibly valuable public resource. The only question left is the one they're asking all of us. What will we build with it?